Hello and welcome back to the channel. Thank you very much for being here. My name is Professor Cunningham, and this is the stream where I do my sort of road to 100% completion of Khan Academy's mathematics course on their website. So for right now, I want to mention that I do this every week at 6 o'clock p.m. as I am starting right now. And though I admit that first and kindergarten grade level math isn't super duper exciting, I will be continuing all the way up through college level math. So within hopefully the next few months, by the end, I should be dealing with college level math, calculus, linear algebra, that sort of thing. But for right now, I noticed that my clasp is showing. Let's fix that. And let's go ahead and take a look at what is expected in first grade. Now, one of the things I want to talk about when it comes to the progression of mathematics education is that after kindergarten, there aren't a whole lot of actual new ideas, all right? And in fact, all of first grade is just taking the ideas that we already learned last time and sort of refining them, generalizing them, and applying them to more and more situations. You don't actually learn that much actual new math outside of kindergarten. Like, once you learn about addition and subtraction and the order of numbers, you've got the foundation you need. So now we're just going to add one small layer of complexity onto what we already know. And again, that's super duper important as a teacher, that we don't present new ideas in math as though they are actually new ideas. Instead, we present them as either generalizations or specific uses of knowledge that we already have. So with that in mind, let's go ahead and check out what the overview and the requirements are for mathematics at the first grade level. So here we are on the Common Core website. Once again, the website is called corestandards.org, and I am specifically using corestandards.org/math for the math curriculum. Now, as before, I will go ahead and read through, word for word, every single word of this page so that you know what your child or your student or your sibling is expected to be able to understand by the end of first grade. And again, since this is a refinement of existing ideas, it's entirely possible that your student, your child, your sibling will be able to get to this point long before actually getting to the first grade in math. It depends. Different people develop differently. So let's take a look. Just checking again to make sure that my microphone is actually recording, because again, last time I did this stream, I ended up talking for 5 minutes to a microphone that was off. And since I don't have a ton of viewers right now, I just wanted to make sure. It looks like I am, so let's go ahead and continue. In grade 1, instructional time should focus on 4 critical areas: developing understanding of addition, subtraction, and strategies for addition and subtraction within 20. So again, same thing as we were doing before. We've already touched on addition and subtraction, but we kept it within 5 and then within 10. So now we're just taking one more little step to do addition and subtraction within 20. And since we introduced the idea of the teen numbers in kindergarten, it should be just a natural progression. Number 2, developing understanding of whole number relationships and place value, including groupings in tens and ones. Now, we did a little bit of that in kindergarten with the 10 frames, but now we're going to be expected to know that like 5 tens and 2 ones equals 52, for example. 3, developing understanding of linear measurement and measuring lengths as iterating length units. In other words, learning how to measure. And I strongly recommend, as students begin to learn more and more about measurement, especially here in America, it's very important to give them a good solid foundation on both the imperial system, feet, miles, pounds, and the metric system, kilometers, meters, that sort of thing. Both are necessary because to exist in the current globalized world, you have to be able to work in both units. And even if you're non-American, because America is still such a gigantic market, it's still a good idea to understand our messed up freedom units. So, number 4, reasoning about attributes of and composing and decomposing geometric shapes. So again, we're going to talk more about shapes. We're going to talk about how to combine them and how to take them apart in order to make new shapes. And we are going to continue to learn how to compare them on the basis of size, position, etc. Okay. So, with that in mind, let's go ahead and take a look at this first big paragraph, number 1. Students develop strategies for adding and subtracting whole numbers based on their prior work with small numbers. Again, we are basing everything that we do on what's already been done rather than trying to tell the students that they are learning something completely new that they've never done before. They use a variety of models, including discrete objects and length-based models, like cubes connected to form lengths, to model add to, take from, put together, take apart, and to compare situations to develop meaning for the operations of addition and subtraction, and to develop strategies to solve arithmetic problems with these operations. So that's just a long and fancy way of saying we're going to keep adding and subtracting, but we're going to keep expecting our students to be able to explain what they're doing and why when they add and subtract. And that focus is going to be so important when they get to middle school and high school, and they will be expected to explain their reasoning on much more complicated topics. Let's see. They use, where were we? Students understand connections between counting and addition and subtraction. So like how counting is just adding 1 over and over again, and how subtraction and addition are basically the same process, but for now we're going to stick to adding to and taking away. All right. They use properties of addition to add whole numbers and to create and use increasingly sophisticated strategies based on those properties, like making tens, to solve addition and subtraction problems within 20. By comparing a variety of solution strategies, children build their understanding of the relationship between addition and subtraction. It is so important that students understand that their method of adding and subtracting is valid, but so are the methods other people use. And I can tell you from personal experience that people do not all use the same method. So being able to understand what other people are doing when they're adding and subtracting will deepen your own understanding of the numbers, so that you can, learn how to, in this case, add and subtract even better. Number 2, students develop, discuss, and use efficient, accurate, and generalizable, there's a big word, methods to add within 100 and subtract multiples of 10. They compare whole numbers, at least to 100, to develop understanding of and solve problems involving their relative sizes. They think of whole numbers between 10 and 100 in terms of tens and ones, especially recognizing the numbers 11 to 19 as composed of a 10 and some ones. And that is such a gigantic part of the decimal system that, again, I see people on social media all the time blasting these kinds of problems, but it's so important to develop this number sense early instead of just forcing students to do one rote action over and over and over again. These aren't factory workers anymore. We're in the information age. Students need to be able to synthesize and generalize. Through activities that build number sense, they understand the order of counting numbers and their relative magnitudes. Relative magnitude just meaning which one's bigger, which one's smaller. 91 is bigger than 87, even though that second number 7 is bigger than 1. It has to do with the tens, right? Okay. Number 3, students develop an understanding of the meaning and processes of measurement, including underlying concepts such as iterating. The word iterating just means you build up, like take 1 foot, and then you add a bunch of those feet together to get something's height. Right? It's just the essence of measurement. But at this age, students are not expected to be able to pull out a ruler and figure out how long something is. That's what this is for. Now, here's some more big words, but I promise I'll take care of them. Let's see. And the transitivity principle for indirect measurement. All right, so that is a really fancy way of saying that if Billy is taller than 5 feet tall, and Sally is shorter than 5 feet tall, then Billy is taller than Sally. That's all it's talking about. if you can take two different things and compare them to one sort of central measurement, you can often tell the relative values of each one. Number 4, students compose and decompose plane or solid figures, like putting two triangles together to make a quadrilateral, for example, and build understanding of part-whole relationships. So we're going to start talking a little bit about fractions, just a little itty-bitty bit about fractions. Not a lot. I think we only go into halves and quarters, and that's it. As they combine shapes, and build understanding of part-whole relationships as well as the properties of the original and composite shapes. As they combine shapes, they recognize them from different perspectives and orientations. If it twists, if it turns, if it reflects, it's still the same shape. Let's see. They describe their geometric attributes and determine how they are alike and how they are different to develop the background for measurement and for initial understanding of properties such as congruence, which comes much later, and symmetry, which also comes much later. Again, we are building a foundation. Let's take a look at the grade 1 overview. So this is just a very basic sort of idea of what each of these topics is going to cover. So for example, operations and algebraic thinking. We're going to represent and solve problems involving addition and subtraction. No problem. We're going to continue learning how to add and subtract. Understand and apply properties of operations and the relationship between addition and subtraction. Eventually, we are going to learn that addition and subtraction are the same process. They are not different at all. They are the same thing. But for now, we want to really focus on the idea of opposites. Right? Adding 1 and subtracting 1 are opposites. If you do both, then nothing happens. Adding and subtracting within 20, again, just increasing our range a little bit more. And then working with addition and subtraction equations. Last time in kindergarten, we showed some equations like 5 plus 2 equals 7, but now students are going to be expected to really interpret them and then write them themselves. Numbers in base 10, extend the counting sequence. Once you've got the pattern down, then all you need is a little bit of vocabulary and you can count as high as you want. Just like when I was a kid and I thought that 109 plus 1 is 1,000 because I didn't know about 110. Well, in first grade is when we learn about that. Working with addition and subtraction equations, already said that. Understanding place value. Understanding that the tens place literally means 10 things. Very important. Use place value and understanding and properties of operations to add and subtract. So again, this is carry the 1. And we're going to talk later about how I think that, quote, carry the 1 is a bad thing to teach. And I think that it's kind of dumb and nobody knows what it really means. But I will teach you what it actually means and maybe give you some better vocabulary to use so that you never have to worry about carrying the 1 ever again. And then finally, use measurement and data. Oh no, we've got a little bit to go. Measurement and data. Measure lengths indirectly by iterating length units. That's like, again, saying that I am 6'3", right? What I did is I took 6 feet, I broke it up, then 3 inches, broke it up. That's my height. Kids don't know how to do that, so we're going to learn. Tell and write time. Now here's a thing that I actually really enjoy because I love challenging my high school students to try to tell the time on a clock that doesn't have numbers on it, and you would be amazed, given how little analog clocks are used these days, how few students actually know how to tell time on an analog clock. Now, that's kind of one of those things that we don't really talk about, we don't really see, we don't really use that much anymore. But, you know, it's still important. I wonder if I can totally turn off all notifications for Google Chrome. Excellent. That way I won't have to get more of those. Okay. And then with geometry, reason with shapes and their attributes, we're gonna continue to talk about triangles and circles and squares, and we're gonna try to put them together to make better shapes or more shapes. And then finally, and I'm gonna zoom in one more time because these mathematical practices are everything. We talk about the 8. Hi, Kistrel, great to see you. For folks who are just tuning in, Kistrel is one of my longtime followers, so thank you very much. And in fact, I've been meaning to mod you for a while, so let's go ahead and do that. There we go. Okay, moving right along. So let's take a look at these 8 mathematical practices again, but this time through the lens of someone going into first grade rather than someone who's going into kindergarten, okay? So number 1, make sense of problems and persevere in solving them. That should be so obvious for any student of math. It's literally what math is about. Try to figure out what is the problem saying, how do I solve it, and then solve it. Number 2, reason abstractly and quantitatively. We are going to talk a little bit about graphs, and we're going to be talking about numbers which are in and of themselves abstract, right? The number 5 is not a thing by itself. We normally expect 5 fingers or 5 sheep or 5 whatever. The number 5 in and of itself is an abstraction. So just dealing with numbers and symbols and numerals is reasoning abstractly and quantitatively. Number 3 says construct viable arguments and critique the reasoning of others. And we talked about that a little bit last time in that, like, is this a square? No, it's a circle. Or is 7 plus 3 9? No, 7 plus 3 is 10. Later on, we will get much more sophisticated at being able to pick out mistakes in the reasoning of others. But for now, it's just important to be able to show an incorrect process to a student and have them be able to point out that it's incorrect. Model with mathematics just means applying mathematics to the real world, which is something we've been doing all the time. Every time we talk about adding and subtracting, we're talking about squirrels, and we're talking about apples, and we're talking about melons, and we're talking about, admittedly, things that might not always be realistic, but they do at least connect to the real world. We can use this addition and subtraction to model real-life activities. Use appropriate tools strategically. Now, last time I told you that we didn't really have any appropriate tools, but now we do. We know how to count, we know how to add, we know how to identify shapes, we know how to compose shapes, and we know how to construct an equation saying like 1 plus 1 equals 2. These are all new tools that are in our toolbox that weren't there when we first started kindergarten, and we are going to use them strategically in order to solve problems going down the line. Mathematicians hate solving the same problem twice. So once we find a tool to solve a particular problem, we want to utilize that tool going forward instead of having to essentially reinvent the wheel every single time. Attend to precision. Now again, this is only first grade, so we're not going to be like going out to 12 decimal points or whatever you think precision means. But when we talk about precision, I think it's important to talk about like the correct vocabulary words. The difference between a rectangle and a square, for example. Being precise in your language, saying what you mean. And again, right now at first grade, at age 6, 7, it's probably not a huge, gigantic deal. But we are laying the foundation for being precise going forward. Look for and make use of structure. Now, there's not a lot of structure that we've seen so far, right? We haven't created a whole lot of structures in our math education yet, but we will. And if you really sort of step back and pay attention to what we're learning, you should be able to see the foundation that we're laying. And eventually we're going to start putting up support beams and making new connections of new ideas and all of that. And then finally, look for and express regularity in repeated reasoning. And in first grade, that means expanding the numbers above 100. Okay? We already know that like 71, 72, 73, 74, 75, that is a pattern that we have been using to solve problems. So when we extend beyond 100, well, 109, 110, 111, 112, that reasoning, that structure, look at number 7, that structure is still there. And we can use that to expand our knowledge of the numbers without having to do a whole bunch of new math. Okay. Now, as a side note, you should know that in this grade 1, if you look directly above my head right now, you should see there are links for all of these areas. And if you really, this is really more of a teacher thing, but if you really want to see every single individual standard, you can look at every single standard, and it has a code, and it tells you exactly what is expected. Now, I don't cover all this stuff on this stream because I think this is more of a thing for professional educators. But if you really want to get into the nitty-gritty of what is expected of a child at a particular grade, this is the way to go. Anyway, moving right along. So with all of this, and Kistrel says, no lie, I wish I had known half these things going through school. Never really occurred to me that it was building knowledge. And that is exactly what I am trying to fight against, because it wasn't for me either. I learned how to carry the one for no reason. I was never told, why do you carry the one? And that's kind of my point here.